continuing our discussion about lesson IN6, linear equations, y equals mx. So y equals mx again, and the m is standing for the slope of our line. These are proportional relationships, so they're going to go through 0, 0. Our slope is going to be our unit rate. So if you look on example 3, a recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. Write an equation that describes the relationship between raisins and granola and graph the line. So what we have to do first of all is make a decision about what our x and what our y is going to be. The book went ahead and made the x be the granola and the y be the cups, or sorry, the y be the raisins. And so you could have done it the other way around, and that would have been perfectly fine. Your graph would understandably look a little bit different by doing it that way, and that's okay. If you choose to do it this way, obviously if we don't have any raisins, we don't have any granola, and we have 2 cups of granola, 1 cup of raisins, that's where they're getting this 0.12. By having a couple points then, we can use that to find the slope of the line. Slope, once again, not how we're doing it there. It's change in y over change in x. So our change in y here, we're going up 1. Our change in x, we're going over 2. So 1 over 2, 1/2 would be the slope of our line. It does go through 0, 0. It is proportional. So kind of like we talked about, we had that y equals kx lesson with our constant of proportionality. It's the same idea. Our slope is the same as our constant of proportionality here. And so the equation instead of y equals mx would be y equals 1/2 x. If you had it switched around with the raisins and granola, then you'd be going up 2 and over 1, and your slope would be 2. Then your equation would be y equals 2x. So different equation just because it's a different order of the granola and raisins if you do it that way. So if we look at the try it part A, they want us to write the equation of this line. So in order to write the equation, we have to have the slope. In order to have the slope, we have to find 2 points on the line. So one point that this line goes through is 0, 0. Another point that this line goes through is 25, 10, right on the edge here. It's slim pickings here. We don't have a whole lot of options. Way over here we have negative 25, negative 10. A lot of people prefer positive numbers over negatives when they're working with it. So if you want to go with the first 2 that we said, that would be fine. So now we need to find our slope. Slope, change in y over change in x. So if we look our y values here, we went from 0 to 10. So our change in y would be 10. Again, you could get that by taking 10 minus 0. Change in x, our x value went from 0 to 25. So our change in x would be 25. Again, if you wanted to work, that would be 25 minus 0, which is 25. So we went up 10 and over 25. As always with fractions, we want to try and reduce if possible. So both of these numbers are divisible by 5, so that would reduce down to 2/5. We have done a majority of the work. We need to finish this off. The question was to write the equation. So instead of y equals mx, our equation would be y equals 2/5 x. Okay, so again, majority like we've been doing of finding the slope, just the finishing touch there of writing what the equation is at the end of that problem. And these graphs right now, they're giving us graphs that are proportional. If they're proportional, our constant of proportionality, rate of change, and slope are all pretty much the same thing. Some cases we'll have things that are not proportional, and in those cases, rate of change and slope always will mean the same thing, or like our unit rate. It's just we won't call it a constant of proportionality if it's not proportional. So part B, they want us to graph the line y equals negative 3x. So this is kind of a little different viewpoint for us. They're giving us the equation and asking us to graph it instead of graphing it and asking us to give them the equation. It's kind of backwards. So for this, what we might want to do is think about this y equals negative 3x. Thinking about that equation, that's in that y equals mx, y equals kx format. So that tells me that it's proportional. Now, everything we've talked about has been proportional, so you might say, well, what's not going to be proportional? Not proportional is going to be when we get into, like, if it was y equals negative 3x plus 5, or y equals 5x minus 2. If they're adding something or subtracting something after it, those are ones that are not proportional, okay? This one is proportional, so we know proportional, it's going to be a straight line. It's going to go through the point 0, 0, right? Okay, so 0, 0, we could graph that point for sure. The question is, what's another point on the graph? I'm not a big fan of them going by 5s here. I'm not sure what made them decide to do that, but I'm just going to actually going by 5s because every other one is not actually labeled. So I'm going to cross their numbers out here because this is going to make a little more sense for us, I think. So this is in that y equals kx or y equals mx. So this negative 3 actually is representing our slope. Slope, we've talked about, it's a change in y over change in x. So if my slope is negative 3, you might say, well, negative 3, I don't have a fraction though, but remember, negative 3, we can put that over 1. Negative 3 divided by 1 is still negative 3. So what we can do using our slope, we can go from that point 0, 0 and use your slope to find another point. So if my change in y is negative 3, change in y is negative, would mean we would be going down 3. And then change in x is 1, we'd be going to the right 1. So down 3 and to the right 1, that would take me to the point, actually, 1, negative 3. And then that actually is enough for us to graph our line here. We are expecting a negative 3 for our slope, so make sure your graph is showing a negative slope when you graph that, which it is. Another option you guys have, we actually did this last year, is we could make a table. So you may or may not remember this whole process, but if we're making a table, what we can do is just substitute numbers in place of x. So if x was 0, we get 0. We usually, if there wasn't a fraction, we usually did 0, 1, and 2. So if you put a 1 in, negative 3 times 1 is negative 3. That's the 1, negative 3 we just got. If you put a 2 in for x, that would be negative 6. So 2, negative 6 would be another point on our graph. Now, how our graph is, now that we switched it to going by 1s, 2, negative 6 is actually going to be off the chart there. But anytime when you guys are doing these, if the book is going a different route as far as the scale or something, and your graph isn't going to fit, you're welcome to use graph paper to get it to where that will fit on there for you. One nice thing about doing it this way with the table is that we're actually getting 3 points instead of 2 points. So with 3 points, the nice thing about that is if I get 3 points and I get them to line up with each other, that kind of is reassuring to me maybe that I've done this correctly. If I have 1 point and I use that point to find another point, if either of those are wrong, I'm not necessarily going to know it. I'm not going to have a double check of having another point and seeing if they're lining up with each other. Okay, so you can do this problem either way. Understand maybe for a long term, this is probably not a bad choice of doing a table just because we have a way of double checking if our points actually line up or not. So if you look at the key concept, just kind of recaps for us. Not the best recap with the numbers they picked for us to look at those points to know we went up 4 and over 1. But anyway, if you assume that they gave us where we could tell we went up 4 and over 1, that is our slope. We're substituting y equals mx, so our equation would be y equals 4x. And I'm getting word now that your book, actually the numbers are different, so where you can actually tell that it goes up 4 and over 1. So that's good that the book made a correction on that part. So if you look at this, do you know how, number 4, relationship between a hiker's elevation and time is shown in the graph. Find the constant of proportionality, then find the slope. Well, like we've talked about a little bit already, constant of proportionality and slope are going to be the same. If it's proportional, those are going to be the same as each other. So we just need to find 2 points on the graph. So 2 points that this line goes through would be 0, 0, and 130. And as we might have mentioned before, it is proportional, so we basically got that 130 like our unit rate point that we basically know what's going to happen. We know what our unit rate is, which is going to be our slope as well. Again, just to practice this, change in y, change in x, we go up 30 and over 1, so 30 over 1, 30 divided by 1 is 30. So 30 would be our slope, and it would be our rate of change. So 30 and 30 would be our answers on part A. And it didn't ask us this, but basically what that's telling us, it's feet per minute, 30 feet per minute that they're hiking elevation-wise. And then part B, they want us to write the equation. So again, off of that basic equation, y equals mx, so our equation would be y equals 30x. So if we look at number 5, they want us to graph the equation y equals -1/2 x. In order to graph this, we have to have at least 2 points, and we are going to be the ones coming up with the points here. So since this is in that y equals kx, y equals mx format, there's nothing being added or subtracted behind it. It is proportional, and so it's going to go through 0, 0. It's going to be a straight line. Now we just need to find one more point. So to find that other point, a couple different options we have. One option is we know from the equation that our slope is -1/2. A slope is a change in y over change in x. So the negative they put next to the fraction, I'd like to put it up in the numerator. And so change in y is -1 means from that point we can go down 1. Since change in y is negative, we go down. And then change in x is 2, we could go to the right 2, and that would get us to another point on the graph. So this would be what the graph's looking like, kind of. when you guys draw this out, a good idea too, if you've got a ruler, or just use the edge of a piece of paper if you want to make a nice straight line, make it a little straighter there, you can. The other option you have, like we mentioned earlier, is to substitute numbers. So y is equal to -1/2 x, so we can just put in numbers. So if we put in, well, if we put in 0, would be 0. We've already found that one. The deal is, since we have a fraction, I could put a 1 for x, but then I'm going to get a fraction that I'm going to have to graph. So since my denominator is 2, I'm going to do multiples of 2 as my points. So if I put in a 2, half of 2 is 1, and then we have a negative, so that would be a -1. Another option, we could try 4. Half of 4 is 2, and we have a negative, so that would be a -2. So 4, -2, and you can see how far my graph is off. I got off the path there a little bit, being a straight line. 4, -2 would be another point. You could substitute numbers over to the left as well. If you put in -2, you would get 1. If you put in -4, you would get 2. And there again, we can see that my line was really not that straight. Okay, again, the idea with the table, getting at least 3 points to tell. If we can get 3 points to line up, that's a good verification that we've done the problem correctly. And again, always make sure, in this case, we're looking for a negative slope. Make sure your graph looks like a negative slope.